What's up, guys? So I'm going to be explaining what a sideload attack is today. So pretty much what a sideload attack in the context of DLL sideloading is, you're going to be replacing a legitimate DLL or a legitimate dependency with a malicious one. And the context of this would be used in, I would say, three big scenarios. The first one would be piracy and cracking. And another one would be the cheating community, so game cheats. You know, if you're swapping out a game's dependencies with an altered DLL, then it will be loading your cheat potentially. And the third big one that I can think of would be malware development. If you're looking for some sort of privilege escalation, you can be replacing dependencies to a high privilege application. So in this case, we're going to be doing an administrator application. And if you are running from administrator, you are going to be able to do things like load drivers, overwrite files, communicate with drivers, right? You're going to be able to do a lot of different things that you wouldn't be able to do running from non-privileged position, where you would only be stuck with your little box of memory, right? So I'm going to show you guys the application that I made just for a little proof of concept. So the application is going to, you'll actually see the source code in the background. We're going to read all three of the source codes in a minute, but first we're just going to start with showing you how everything works. So the application is going to be loading DLL for certain functions. Loading the DLL for certain functions. And when we run it, it's going to say, please enter a PIN. And the PIN is going to be 1234. And if it's correct, it's going to say valid, right? Cool, that's pretty straightforward. And then we'll do it again, and I'll show you guys what invalid would look like. Just type in a random number, it's going to say invalid, right? Pretty straightforward. Now, what happens if I'm going to just comment this out? It's looking for DLL.dll. So if I comment it out, it won't run properly because it won't find that DLL. But let's say I overwrite that DLL with our malicious DLL, right? And then we run the application. It's going to say, please enter a PIN. We're going to type in the PIN, and all of a sudden, calculator spawns in. I have these two windows as topmost, which is why everything's underneath. But how is it possible that calculator has just spawned in? Well, we'll go over it in a minute. It's because obviously it's a malicious DLL now. But we kept the legitimate logic, so it's still going to work properly. The application is not going to be like, just crash or something. It's still working properly. I can even show you guys it failing. And look, it still spawns in the calculator, but it shows that it's invalid, and the application is still running the way that it was intended to run, except it's doing extra work, right? So we're going to go into the source code. So in the source code, I'm not going to go line by line and explain everything. I'm hoping that you have some sort of level of computer science knowledge. So pretty much what we're doing is we're loading DLL.dll. We're doing 0 integrity checked on it. We're not making sure that it, is the same sequence of bytes as we're expecting. No, we're just loading the DLL, right? Then we're going to go and import our check pin function from the DLL, right? So we're passing in the H module, which is, remember, the handle to the DLL. And then we are going to search for the check pin function, and then it's going to compare the pin that the user enters. Down here it's going to call check pin and pass in the pin that the user enters, and then it's going to print out whether or not it's valid or not, right? So we'll go and look at the DLL code now, which is actually probably a lot shorter than you would expect. So it's literally just this, right? All it's doing is, stating a couple different things: the calling convention, the fact that it is a DLL export, and then the return type, the function name, and the argument, the parameter, which is going to be the pin. And all it's going to do is just return whether or not the pin is 1234. Pretty straightforward. Now the custom DLL is the exact same thing, except with an extra line of code. So when the legitimate application loads this DLL, it's still going to find check pin, and it's still going to run the same code to check whether or not the pin is valid. But it's also going to be able to run this line of code, which is our line of code. Now, the way that this would tie into something along the lines of cracking is if we go and swap this out, we could simply say return true. And now whenever this application is going to go and check whether or not you have a valid license, you can just return true, and it'll just continue on. There might be a couple different places where it checks, does it have a valid license? What's the account name? It might do a couple different things, and you might have to replace a bunch of different functions, but still here, the idea is the same. You are overwriting it with what it wants to hear, which is that it's true. The pin is true. So if we went and compile this right now, we're going to see a whole bunch of bloat show up down here. I'll try to filter it out a little bit. Okay. And then we have the DLL. we go and run it, we can type any pin now. We can type any pin and it is valid, right? So that's kind of how the cracking would go. But you also have to think about the fact this is an administrator application. This is always being ran as administrator. Considering that you can simply swap out a DLL and have administrator access on somebody's computer, and you also can incentivize them by saying, oh, it's a pirated software. It's the patch to a software, right? Or it's a cheat for a game, right? You can convince people to swap out. They're not thinking in their head, oh, I'm gonna run this random person's code as administrator. Of course they're not thinking that. They're thinking, oh, I'm just swapping out a file. I'm just swapping out a file that's not like they're not clicking administrator. They're literally swapping out a file, and that is enough for us to be able to run administrator code on somebody's computer, a privileged code on somebody's computer. So yeah, that's the sideload attack, kind of simple, straightforward for you guys. All right, round 2. So this time we're going to actually reverse a real software, and we're going to implement this idea of the sideloading. So I just chose a random application on my computer that runs from administrator, which I just chose Revo Uninstaller. Shout out to Revo Uninstaller, W Software. And I'm just going to follow the path to the actual application. You can see that it forces you to, over here in compatibility. Oh, I thought this checkbox would be plugged in, but pretty much it just forces you to run it as an administrator. All right, so I chose Revo Uninstaller. And what I'm going to do is I'm going to copy the path to Revo Uninstaller and then open it in IDA. Now in IDA Pro, I'm going to choose on Revo Uninstall. This is the main application. And then we have this. I'm just going to click OK with these. And I'm going to load the. I don't think you'll be able to find the PDB. Maybe for certain things. Let's see. Okay, it did not find the PDB. Okay, cool. Revo Uninstaller imports. So there's actually a lot of things in here. And all of these have a lot of imports. And they're also probably pretty important. Like, we probably don't want to change anything in kernel or user 32, right? Let's look for something that we think is not going to be too important. So, WinMM, play sound. Do we need to play sounds? No. And this is probably either a bool or a void return type. So it either doesn't return anything or it returns your true or false. So this is probably going to be the easiest. And I'm just saying that just because imagine play sound, what would it really be returning? You're not asking for anything in particular. So, okay, let's go ahead and reverse Win32 or WinMM, sorry. So if I open up my system32 and I just type winmm.dll, okay, hold up. WinMM, there we go, winmm.dll. So we're not going to be able to touch anything in our system32 by default. Maybe you will. Maybe if you have some sort of change on it. But we're going to go to what I'm going to do is I'm going to go to security. I'm going to edit permissions for myself, and I'm going to allow for full control. Cool. I'm going to click OK, and I'm going to move WinMM. Actually, before we move WinMM, let's reverse WinMM. Okay. So we're going to, we're going to open a new file system. WinMM. All right, so we're going to open up WinMM in IDA. And we probably will get a PDB for this. Yeah, I think so. Okay, cool. So now we're going to go and we are going to look for, in the exports tab, we should be able to find play sound. Yeah, play sound. So was it play sound A or was it play sound W? Let's go take a look. It's play sound W that matters. Okay, play sound W. And okay, so we get this syntax here, and we can straight up just copy and paste this. And like I said, the return type is actually a bool, so that's pretty cool. It's just probably returning true or false depending on whether or not it ran properly. So let's go into our DLL and let's just straight up paste that in. Okay. Now we're going to do a little bit of modification to our play sound W here because it's going from being an actual like function header to, it's still going to be a function header, but we're going to be exporting the function. So we're going to do extern C. There we go, DLL export. And then we can take our function header and throw it right on top of that. And bam, this should work. Now, we're not going to just leave it we're not going to just leave it declared and uninitialized. We are going to actually go and just straight up return true. Cool, cool, very nice. Okay, so next, here is our entry point. I know I didn't use an entry point for the example that I used before, but pretty much this gets called, the entry point gets called under 4 conditions: process attach, thread detach, and process detach. So we're going to be wanting to call our code right when the DLL gets attached to the process. So the way that I'm going to do this is I'm going to go into here, and I'm just going to write some code that's going to be called the second that the DLL gets attached to the process. So it's going to be something like calc.exe, and then I'm going to return, or sorry, not return. I'm just going to break. Okay. Now, let's take a look at what we've done so far, because this should work. Extern C is going to be our exported function, so that if the application does try to run the function, no, the audio will not play, but it's not going to crash the program because it's just waiting for a return, and it never gets that return. Okay, cool. And that's pretty much it. So, and then we're also going to be calling our own command, breaking from the switch statement. Cool. Let's go ahead and build it, but before we build it, I have the project name as WinMM Emulator, but I actually want to change it to, let's change the target name to exactly what the Revo installer is looking to import, which is going to be just straight up WinMM. And let's go and build our project. Open this in File Explorer, go to the build folder, and we have our WinMM DLL. I'm going to copy this, and I'm going to go into my System32. And now that I have my rights over WinMM, I'm going to just throw this onto my desktop for now, and then I'm going to paste over my modified WinMM. So theoretically speaking here, when I open Revo on installer, we should see a calculator pop up. Very nice, everybody. Okay, cool. I mean, yeah, that's pretty much the whole idea. It's like you can execute code, and that's executing from an administrator point, right? Now, usually would you have access to overwrite something in somebody's System32? The answer is no. But if you can get like something that's not in your System32, in this case, it was the most easy for us to do do this file that's in System32. But you know, there's not millions, but there is tens of DLLs, maybe hundreds of DLLs that are getting imported, depending on the size of the application. You can just find one to target specifically, right? So that's pretty much the whole video for you guys. See ya.